Imagine a day with a clear, sharp sky. There's a nervous energy in the air, a kind of hum you can feel more than you can hear. Then, slowly, it comes into view. A massive carrier emerging on the horizon. It's not just big, it's a geological feature that has decided to go for a swim. The world gets its first proper look at the USS Gerald R. Ford. Its scale is genuinely difficult to process. People stare, cameras zoom in, the mind refuses to compute the size. This isn't just another ship sliding out of a dry dock, it's a statement, a declaration in steel, nuclear power. A new era of naval dominance has begun. The water churns, the crowds gasp. A piece of the future has just become the present. The reveal is less of a launch and more of a national event broadcast across the globe. For years it was just a name, a set of blueprints, a staggering budget number, sleek angular flight deck. The imposing island superstructure set further back. The sheer unyielding gray hull. It looks like science fiction, but it's science fact. Decades of research, ambition, tugboats guiding the colossal vessel into the channel. You realize you're watching a symbol of national technological prowess, a promise to maintain power across the oceans for decades to come. Let's talk about the numbers because they are genuinely staggering. The USS Gerald R. Ford cost around $13 billion US. That's a B. To put that into perspective, you could build several of the world's tallest skyscrapers for that price. Eiffel Tower, Empire State Building. It's a sum of money that is almost abstract, a figure that represents an incredible national investment. And this is just the cost for the first ship in the class. That budget pays for more than just steel. It funds research and development for entirely new technologies that have never been put on a warship before. It is, without a doubt, the most expensive warship ever built. A title it will likely hold for quite some time. The carrier's size is just as difficult to comprehend as its cost. It displaces over 100,000 tons of water. That's the same weight as about 400 Statues of Liberty. The flight deck covers about 4.5 acres. You could comfortably fit 3 professional football fields on its surface, with room to spare for the spectators. From bow to stern, it measures 1,106 feet, or 337 meters. If you were to stand it on one end, it would be taller than the Eiffel Tower. It is a man-made island designed to move at speeds over 30 knots. The journey from a blueprint to a fully operational supercarrier is a monumental undertaking that spans the better part of a decade. It all begins at one place in the United States, Newport News Shipbuilding in Virginia. This is the only shipyard in the country capable of building and refueling nuclear-powered aircraft carriers. The process starts in a massive dry dock, a sort of concrete basin the size of a canyon. Time-lapse. Keel block to completed hull. Enormous steel sections, some weighing as much as 900 tons, are carefully lifted into place by a giant gantry crane named Big Blue. These modular blocks, prefabricated with wiring and piping already installed, are set in place. Welders join blocks with precision, forming the hull. As the hull takes shape, the site looks more like a sprawling construction site than a vessel. Thousands of shipbuilders swarm over it daily. Welders, electricians, pipe fitters, engineers. The 2 nuclear reactors which arrive as sealed units are lowered deep into the heart of the ship. This is one of the most critical and sensitive parts of the entire construction, until the island superstructure is finally lifted into place, completing the carrier's iconic silhouette. After several years of construction, the dry dock is flooded and the ship floats for the very first time. Only after it has passed every test, from flushing the toilets to launching aircraft, is the ship officially commissioned and delivered to the Navy. So, what makes the USS Gerald R. Ford so different from the 10 Nimitz-class carriers that came before it? The answer is, honestly, almost everything. While it may look similar from a distance, it actually represents a fundamental redesign of the aircraft carrier concept. One of the most noticeable changes is the island, which is the command center of the ship. It's smaller and positioned much further aft, or, towards the back of the ship. This seemingly simple change has a huge impact. It opens up a massive amount of valuable space on the flight deck. Here's a clear comparison of the flight deck layout on a Nimitz class versus the Ford class, which allows for more efficient movement and staging of aircraft. What this really means is that the ship can launch faster than any carrier before it, and recover planes faster than any carrier before it. The entire ship was designed with a focus on generating and managing electrical power. The new A-1B nuclear reactors produce nearly 3 times the electrical power of the reactors on the Nimitz-class carriers. And this incredible power surplus isn't just for show, it's actually essential for the next generation of naval technology. It powers advanced radar systems like the dual-band radar. For over half a century, aircraft carriers have launched planes using a system of steam-powered catapults. It was a reliable, if somewhat brutal technology. Basically, it worked by building up a massive amount of steam pressure and releasing it in a controlled explosion to fling a 30-ton jet off the deck. The Ford class does away with this system entirely. Instead, it uses something called the Electromagnetic Aircraft Launch System, or EMALS. This is essentially a gigantic linear motor. The same basic technology you might find in a modern maglev train, scaled up to an incredible degree. It uses powerful, precisely controlled magnetic fields to accelerate the aircraft down the track, smoothly and quickly. Unlike steam catapults, which basically have one launch setting, very, very fast, EMALS can be finely tuned. The system's software can be programmed to provide the exact amount of force needed for a specific aircraft, whether it's a heavy, fully loaded fighter jet, or a much lighter, unmanned drone. It also provides a smoother acceleration, better for pilots and onboard electronics. An aircraft carrier like the USS Gerald R. Ford is much more than just a military asset, it's a powerful tool of foreign policy. When one of these ships sails into a region, it sends a very clear and unambiguous message. It's a concept known as gunboat diplomacy, a single carrier strike group, which consists of the carrier itself plus its escorting cruisers, destroyers and submarines, represents more military power than most entire countries possess. Its presence can reassure allies, deter potential adversaries, and stabilize a volatile region simply by being there. It is 100,000 tons of sovereign American territory that can be moved anywhere on the globe. The strategic significance of this mobile airbase cannot be overstated. In times of crisis, the first question a U.S. president often asks is, where are the carriers? In the end, the USS Gerald R. Ford is more than just a ship. It is a floating testament to the limits of engineering. It is a symbol of national ambition. It is a preview of the future of warfare, from its nuclear heart that will beat for decades without refueling, to the invisible magnetic fields that catapult aircraft into the sky. Every system on board represents a leap into a new technological era. The sheer scale of the project is enough to leave you staggered. Its $13 billion price tag, its city-sized dimensions. But it's the innovation packed into every corner of its steel hull that truly defines its importance. This is what the next 50 years of naval dominance looks like. We have seen how this ship redefines the very concept of an aircraft carrier, introducing electromagnetic launch systems, streamlining rearming and faster sortie generation, the ability to generate a third more sorties per day, more planes in the air, a faster response to threats. It is not just the future of naval power. For the men and women who serve aboard it, and for the world that watches it, that future is already here, and it is absolutely awe-inspiring.